Hi everyone, welcome to Day 4 Challenge. Today we're gonna tackle the hardest question number 6. First of all, the answers are B, D, and C. Did you get them correct? Alright, let's look at the first one. Laura added two 3-digit positive integers. All 6 digits in these numbers are different. Laura's sum is a 3-digit number s, so what is the smallest possible value for the sum of the digits of s? Alright, so the thing is, first you add up like two 3-digit positive integers, and as for s, you want to make all the digits as small as possible. So in order to guarantee that, I first choose 2 zeros for the unit digit and the the 10th digit. So the next thing I would do is to minimize the 100th digit, because I know it's not going to be zeros, but I still want to minimize it. Alright, so I do care about what are the 100th digits for the two original integers. So since all 6 digits are different, so I might choose some different numbers. So the two smallest numbers from 1 to 9, so let's do 1 and 2. And after I add them up, the 100th digit for s might be 3. And now I was thinking about, is it possible that like the two 3-digit integers add up to 300. So in order to guarantee the 10th digit is 0, there must be a carryover 1 right over here, right? So it's not possible that the 100th digit in s is 3. Instead, it's possible that it's equal to 4 since there is a carryover 1. And it's really easy to find a pile of solutions, let's say. For example, 193 plus 207, and it works. They add up to 400. So the smallest possible value for the sum of digits in s is 4 plus 0 plus 0, which is option B. Alright, the next one. A box contains 5 chips numbered from 1 to 5. Chips are drawn randomly one at a time without replacement until the sum of the values drawn exceed 4. So what is the probability that 3 draws are required? So first of all, like in order to interpret this question, we need the first 2 draws. The sum of the numbers in the first 2 draws are less than or equal to 4. And now we're thinking about the possible scenarios. So since we want it to be like small, we want the sum to be small. Let's start from the two smallest number, 1 and 2. So if the first number is 1, the second number is 2. Yes, you need the third draw. And what if it's 1 plus 3? Oh, it's equal to 4, but not over 4. So still you need the third drawing. But 1 plus 4 is already exceeds 4, so it doesn't work. So let's thinking about the scenario when the first number is 2. So 2 plus 1, of course, it works. And 2 plus 2, we don't have another 2, unfortunately. What if 2 plus 3? 2 plus 3 is 5. It's already over 5. It's already over 4. So it doesn't work. And let's start from 3. So 3 plus 1 is equal to 4, and it works. You need a third draw. And 3 plus 2 is already over 4, so it doesn't work. And in total, you find 4 different cases that satisfy the criteria we have that is mentioned in this question. Okay, and now let's focus on the first scenario. So the probability that the first number is 1 is just 1/5, because in total you have 5 numbers. And what is left is just 2, 3, 4, 5, and the second draw, you want to take out 2, so the probability is 1/4. And you will find that is exactly the same when you do the analysis for another 3 cases. So just times 4 directly in order to find out the probability. So that is equal to 1/5. So the answer is 1/5, option D. Alright, the last one for today. Miss Blackwell gave an exam to 2 classes. The mean of the scores of the students in the morning class is 84. In the afternoon class, main score is 70. So the ratio of the numbers of students in the morning class to the afternoon class is 3 to 4. Oh, so we know the ratio. What is the mean of the score of all students? Alright, and I think everyone knows how to find out the average, right? So just add up all the numbers and divide by the number of terms. And now, since we don't know the number of students, but we do know the ratio, right? So a typical way to do this kind of question is we assign a variable. Let's just assume the number of students in the morning class is 3x, and correspondingly the number of students in the afternoon class is 4x. All right, now let's do the calculation. So we need to add up the scores of all the students. As for the morning class, if you add them up, that would be 3x times 84. And as for the afternoon class, if you add up all the scores, that would be 4x times 70, and divided by the number of all the students. So 3x plus 4x is 7x. And now something good happened because all the x terms, they just cancel out, and you can find the number result. And after you do this calculation, you'll find it's equal to 76. So we choose option C. Alright, that's all for today. See you next time.